Hello, class. So we're going to do the second example of finding the domain and range using the graph of a function. And again, we're going to express it in interval notation. So unlike the other graph, this one here has arrows. And remember that when a graph has arrows, it's telling you that it goes on forever in that particular direction. And then here it goes on forever in this particular direction. It never actually stops, okay? Um, so we want to look at the domain again. So remember the domain, we want to look at input x values, okay? In the range, we want to look at all the possible output, and in this case is y values, okay? So again, let's look at what we were doing in the previous example. Let's start with domain and go in increasing order. So here are all the x values, and we want to start by asking ourselves, is there a smallest x value corresponding to a point on my graph? Visually, it looks like -4 is the smallest x value, but because this graph is actually still going, right, it's actually continuing on forever, forever, forever. So there, -4 is not the smallest x value, neither is -5, neither is -6. So in this case, there is no smallest x value that is an input to my function. It just keeps going on forever and ever and ever. So the way you mathematically write that something is going on forever and ever and ever numerically in the negative direction is we use negative infinity. So we're going to say there is no smallest x value in my domain. It keeps going on into the negative infinity direction. And because that's not a number, we will always put parentheses. We can't include it. Okay. So this is mathematically saying there is no smallest X input value. It just keeps going. You can plug in any negative X value that you want. It just keeps going on and on and on. And similarly, if I want to look at what's the biggest X value that I can plug in, the arrow here tells me that this keeps going on forever and ever and ever and ever. So 2 is not the biggest X value, neither is 3, neither is 4. It keeps going on forever and ever and ever, but in the positive direction. So mathematically, we write this with the symbol positive infinity. And because it is not a number, we always put a parenthesis, okay? So this is telling me that I'm able to plug in any x value that I want. There is no smallest or no biggest bound, okay? So let's take a look at the range. So range is all about the y values, and we want to go in increasing order. Now, if I was to erase these pictures here, you might be tempted to say that, oh, -6 seems to be the smallest y value that will become an output. But because this graph goes on forever in the going down forever, notice that -7 is actually a point on the graph, and sorry, the y value -7 corresponds to a point on my graph. So it is an output value, and therefore it is in my range, and so is -8, and so on. So there really, because this arrow is telling you that it's going down forever, there really isn't a smallest y output value. So therefore we need to put parenthesis negative infinity to say there is no smallest y output value. Now, is there a largest y output value? Well, again, you might be tempted to visually see that 3 is like the peak, so it's the highest possible y value. But because this graph is telling you that this is going up forever and ever and ever and ever, there's actually 4, right? 4, the y value 4 corresponds to a point on my graph, and 5 and 6, and it keeps going up forever. So there really isn't a largest y output value. It keeps going on forever and ever and ever. So we're going to put positive infinity for that as well. All right. So don't get it confused. Make sure you look at the arrows. If this graph had endpoints like this instead of arrows, then yes, then that would change the problem a lot. But because it has arrowheads, it's telling you that it goes on forever. So just be careful, okay? All right.